So we are going to solve a very simple problem today. Let's say a ball falls from the height h to the ground. Then what will be the final velocity at which it will hit the ground? So how do you calculate this? Now there are two ways in which you can calculate this. First method is by using the kinematics equation, and second is by using law of conservation of energy. So first equation says v square is equal to u square plus 2as. So v square will be u square is 0 because the ball is just released, no velocity is given to that. So initial velocity is 0. Acceleration is g and distance covered is h. So you can see that v is given by under root of 2gh. Now we are going to derive the same equation using the law of conservation of energy. So law of conservation of energy says that energy cannot be created, it can be converted from one form to the another. So when the ball falls from this height to the ground, what is happening is that when the ball is at specific height, because of its height, there is a potential energy. Okay, and that potential energy gets converted into kinetic energy. So we can write this equation: potential energy is equal to kinetic energy. So potential energy is mgh because the ball is at height h and g is the gravity. Now kinetic energy is given by 1 half mv square. So total potential energy lost during this transition is mgh because initial was mgh and then finally height is 0. So at this point when the ball hits the ground, its energy will be 0. So the change in the energy is mgh, which will be equal to kinetic energy, right? At that point when the ball hits the ground. Let us say the velocity is v at that point and we know the mass. So you can see here m get cancelled out and we can write v square is equal to 2gh. So v is equal to under root of 2gh. So you can see that this equation and the equation over here, they are one and the same thing. So when something is falling on the ground or something is rotating, there is always some kind of energy associated with that object. There can be several ways in which you can solve the problem. For example, in this situation, we have used kinematic equation as well as law of conservation of energy to solve the problem. So always give preference to this law of conservation of energy when solving the problem. If you are not able to solve the problem using this technique, then only you can explore other techniques. Thanks for watching.